Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast. Welcome back to the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from Tamaki Makaurau, Auckland in New Zealand. And this week I'm joined by Zach Semke. How are you doing, Zach?
I'm doing well. How are you, Matthew?
Pretty good. And we've also got Mary James joining us again. How are you, Mary?
I'm great. Thanks. Well, as good as can be given the current circumstances. Trying hard to ignore.
Yeah. Zach and I made a conscious effort to not really go there last week, but I was thinking about it just before we jumped online. I thought this is quite a good interview to get stuck into because it reiterates some of what I've been thinking is that there's some really good stuff going on, and I think we should focus on that. And some of the reasons behind this project and some of the motivations and some of the learning, I think are quite encouraging. So that's what I'm choosing to focus on, at least for now.
You're here.
Absolutely.
Well, I'd like to get into it because I think this is a great interview that you did for us, Mary. So we'll get stuck into that. But before we do, we got a few people to thank, Zach.
Indeed. So I want to start by thanking our accelerator partner of the week, which is Curtis and Ginsberg Architects. So thanks to Curtis and Ginsberg for making our programming possible this week. I also would like to thank our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority, and our founding sponsors, 475 High Performance Building Supply, Ingwe Architecture, Partel, Rockwell North America, and Zola Windows. And thanks to our champion sponsors, Buizo, Icon Windows and Doors, Intelligent Membranes, and Source 2050.
All right. Mary, tell us how you came across David Komet.
Well, I spoke to David Komet because I had heard him give a presentation for the Passive House Network on his pickleball facility that he's in the midst of developing, started construction recently. And I thought, wow, a pickleball facility. This has got to be the first one ever in North America, certainly, possibly the world.
Yeah.
So, David Komet is with Urban Earth, and he's a developer and a certified Passive House consultant. And he's based in San Antonio, Texas. So, and his firm has a particular focus on creating earthen buildings. So I spoke to him about that, the actually prefabricated panels that are made with autoclaved aerated concrete, also known as AAC, and about designing for the needs of the hot and humid climate where he is, and about pickleball.
Right. Awesome. Let's get into it because there's a lot of really good stuff in here, and from a really great perspective of a developer who's getting their head around PHPP. So let's jump in and we'll have a chat afterwards.
So I'm curious, did you first get the land and then think, oh, I'm going to put a pickleball facility here? Or did you think, I want to build a pickleball facility, where can I put it? And then you found the land. So
that's a great question. So we had the land, and in the last few years, like many places in the country, we had some pretty serious land inflation. And so, as professional investors, it's time to maybe think about monetizing this asset. How are we going to do that? And the answer is always, well, we need to add value, i.e. develop it. So no, I was doing something completely different when somebody that I knew very well came to me and said, hey, we take a look at this. I want to propose you do a pickleball facility here. So I took a time out and we analyzed it. And on many levels, we're now the highway is our ally, not our enemy. So many things were just kind of clicked into place. We did a financial analysis. This is a better performing project. And so we literally pivoted on a dime because we were on the 10-yard line ready to score. And we were deep, engineering, architectural, really deep when we pivoted. And I'm glad we did because it is a better use for the land. It is a better project, it's a better use for the community, frankly, because it adds a sports component to it, an activity component.
Why is that better use for the land? Because the highway is so close, or?
Yes, it literally borders the highway.
Right.
So if you're going to do a residential community, now you're fighting the highway, both in terms of noise and in terms of air pollution. So in terms of the business side of it, the highway being there is not really an asset. For pickleball, it's 100% an asset. So it's really a more appropriate use of that land than putting any kind of a residential, we had neighbors in the community ask us to put a gas station there. So this is just a way better, and the city's thrilled because they're getting, like many municipalities, are being pressured to add courts, to convert tennis courts. And so we brought them a use that saved them money, was appropriate for the zoning base, and was really more of an asset to the community. And for us, was a better business proposition.
Did you have to do anything to the site to make it suitable before you started doing any construction of the facility?
No, I mean, the site is already what I would call a disturbed site in terms of being urban infill. And it sat at the bottom of the watershed with about an 18-foot drop from top to bottom. So we had quite a bit of erosion and things that we would look at from a permaculture perspective. So I'm certified permaculture professional. And so that's why I did that training, because I'm extremely interested in the nature part surrounding the building. Mm-hmm. But we didn't have to do anything beforehand. What we're doing it now for construction, obviously we're having to do things on the site in terms of earthworks, et cetera.
A pickleball facility has to be fairly flat. And yet you said there's an 18-foot drop?
Yes.
So
right.
How are you managing that?
The original construct was to just stair step the building down. The challenge there is it disrupts one of my agendas, which was to make the building extremely accessible. So once we started introducing stairs and things of that nature, and now we're talking lifts and ramps, and so instead we decided to use the slope to our advantage, which was to drop it 6 feet on the northern boundary of the building and burn the building into the hillside.
Right.
So from a passive house perspective, now I have a external wall to ground versus external wall to ambient. So it helps us with our performance a little bit there as well.
Great. Moving on to the building design and material selection. First of all, how did you choose the architect that you're working with on this facility?
We chose an architect based on our experience in the community. We do a very different development model. We don't start with architect, we start with our development team, and we typically start with the engineers. So I, along with our contractor, we specify materials for performance and for constructability first before we even commission design. And then we do the preliminary layout, and then we bring the architect in to make sure we're code compliant, to deal with issues of ingress, egress, all the things that you have an architect do. But the architect is a part of the development team. They're not leading the project. We lead the project. And so we have a designer who's on the team who we worked with quite a bit, who understands how we like to build and how we like to assemble these buildings.
It sounds like that's someone you have a long-term relationship with.
Right. So all that kind of comes under my entity, which is Urban Earth. Mm-hmm. And then we have a contractor we like to do primary work with, which is Modern Earth.
Okay.
And we work with them a lot because we do earth and building projects, mm-hmm. but they're just master builders. We're just very happy with them.
Great. Did either the builder contractor or the architect have previous passive house experience?
No.
So that really is all on you.
Correct.
Which is challenging. It's not the formula for success because this is your first passive house project, right?
Yeah, it is. I would actually say it is a formula for success. And the reason is we've been working hard to deliver well-performing buildings based on materials for our climate. So earthen buildings we're into because if I look back 200 years ago and said, well, how did people solve for climate then? It was adobe, right? So earthen buildings is part of the vernacular here to begin with. We already have a deep knowledge on how to assemble these buildings. My builder's also an architect by training. And we have, I don't know how many combined decades of experience in building and assembling, et cetera. So we start value engineering from day one. My struggle in the past, and this is not knocking architects, is, if I'm an uninformed or uneducated client, that I'm saying, hey, I want to do a passive house, design me something that, looks, and now we're looking at aesthetics the whole time. Versus the way I approach it is, well, what's our primary energy source? Well, it's going to be electric. Great. What's our mechanical strategy for this building? Because mechanicals are so important in this climate. Great. Now let's build a building around that. So that's kind of our approach. So we don't lead with architecture. Architecture is part of the process, but we lead with materials, and we lead with performance, and we lead with mechanicals.
You did your own PHPP for this project, is that correct?
I put the building together and designed PH, and then I ran my own PHPP. Yeah. And then I'm working with, because it is my first building, I did reach out to a few passive house consultants around the country. And then I ended up working with Andrew Peel of Peel Passive House in Canada. Mm-hmm. Really just I just call it training wheels on my tricycle. What's this for? I've since figured out other ways to kind of do the coaching and all that, but certainly they were instrumental in helping me navigate the PHPP, because as I mentioned, I thought that, this would be really easy. No, this was actually really hard, because now I'm into the 7 auxiliary sheets. I've got just so much more dimension to this. It's so many cubic feet of air, and I'm into this giant box coming from Sweden. It was way more complicated than I thought this would be. I thought it's one big box. How hard could this be? And the answer is pretty complex, because I have people running around, I have people standing around. Now we're calculating all of that. So we certainly designed and specified materials that were non-negotiable, right? I know they work here. I know we're code compliant, and I know that we're meeting all of the passive house design methodology concepts using this material set.
So for this one, you decided to work with a panelized material.
Yes. Right? Yes.
Panelized AAC. And
yes.
So why that material?
So let me start with the thesis that we love thermal mass in this climate. And the reason we love thermal mass in this climate is the graph I showed where we're shaving off those peaks.
Right.
And for years, I had HVAC professionals tell me, look, air conditioning really is a 16-degree delta. It's not going to be 110, you're going to get it to 60. That's an unrealistic expectation. So that kind of was part of our thinking, which is like shave off these peaks, then I have a little lower load on my mechanical equipment and a lot less variability, right? Because we can get fluctuations here from 70 to 105 in a day, and then back down. So we can get that kind of dynamic. And so we just love thermal mass. Well, I would have built this out of rammed earth if for no other reason than what a cool project on Interstate 35, rammed earth, San Antonio. It would have been, right? That would have been amazing. But I can't, because now I have to think about circular economy. What if pickleball goes away? Which I'm not worried about that. But what if it did? Or what if somebody offered to buy the building? Or what if it has to be a building that can be repurposed. So what's a material that will give me the thermal mass I'm looking for, that I can rework and repurpose and cut a window, cut a door, and mess with this material? And I'm very familiar with Hebel because it's made about 5 hours south of here in Monterrey, Mexico. And so I've known about Hebel for a long, long time. We've looked into using it for projects for years. This is the first time where it was a fit for us. And so what it's giving me is a faster way to build that thermal mass assembly than doing rammed earth, since I can't do rammed earth anyway. It gives me great balance between thermal mass and insulation. Love that about the product. It gives me some acoustic benefits because it's a little bit porous, so I get some noise dampening, which is beneficial. On and on and on. I actually don't need to do anything to the inside of the wall. Now I will paint it on the first 8 feet so I get a contrast for visual play benefit, but I don't have to do anything. And that's one of the things we love about rammed earth. Once I put it in, it's my structure, it's my insulation, it's my interior and my exterior sheathing. It's kind of a one and done approach, and the Hebble's similar. If it was my house or your house, maybe you want to, paint or decorate, you'd want to do something. But it's a sports facility.
Right.
Number one. Number two, the natural color of AAC is a white color anyway. And when and this is my experience from controlled environment agriculture. If I'm spending money, if I'm putting carbon in the air, providing light, then I want to have maximal light value. And we want the reflective properties of the white surface. So it was already like that. So to me, we're always looking for opportunities to not have to do something.
Right.
And so if I can get rid of several steps in a process, I'm just more efficient. It's more cost effective.
So what's the structure?
So the panels can be structural. In this application, they are not structural. We're using it's a portal frame steel building. And then the panels sit just inside, and then there's just a clip system that ties it in. So it's tied into structure, and it is structure, but it's not carrying the load of the roof at all.
So from the inside, do you see the steel structure then?
Oh, yeah. One of the things I did that's a little bit unusual is I have what's called a triangular truss made out of tubular steel. It's called a space frame. Mm-hmm. So it's just different looking, kind of interesting. It's not your standard, web truss. It's a triangular tubular steel space frame. Okay. So that's the only thing I did to upgrade the visual on that, which I think is going to be a good investment.
Great. That really simplifies the discussion of what's the wall assembly like.
Yeah.
So what is the thickness of it?
Oh, so we're 8 inches. So by code in our climate zone for a thermal mass wall assembly, you need an R6 assembly, and we exceed that, whatever. I'm not even looking at the R value. I want the thermal mass value.
Is it more important to have R value in your roof assembly?
Here it is, 100%. Yeah. So prescriptive code here is an R38. I think for this kind of a building type, it's maybe actually an R25 even. And we're in an R40.
And tell me about your roof assembly.
So again, super simple. I'm using a metal sit panel. So I have my actual roof panel, white. And that's another big thing here. There's been some studies done here by our local utility that just paint your roof white. It's actually more effective and less expensive than a green roof. Green roofs have other benefits like stormwater retention, all that stuff. But for temperature here, no. And that's what we spent a lot of our time on, is the value engineering around what is worth investing in and what is not in our climate. And so an R20 wall is all you need here. But even if I had an R10, if I'm super airtight to the passive house standard, that still outperforms an R40 wall that's leaky. Mm-hmm. So that because of the climate being hot, humid, we don't want to be sucking hot, humid air into this building.
Right.
But so that's why I said this is so simple. I've got a slab on grade. I've got a metal skeleton. I've got Hebel skin on the walls, and I've got a sit panel metal roof, and that's it. A little bit of storefront glass and a door.
That's great. And you said no insulation under the slab?
Correct. We don't need it in our climate zone. Where we do need it is if this is grade and we have an exposed slab edge, which is very common here. For sure, you want to detail that, right? Because that's just a heat highway into the building. And so we'll put rigid insulation or berm up against that, or we'll have a strategy for that.
Okay. And let's see, delivery. You talked about how important integrated project delivery and team collaboration was. It sounds like, in a way, that's pretty easy for you because you have your team a little bit baked into your whole process.
Yes. So this project, I stepped our game up a little bit. I'm working with a designer / architect I've never worked before. I'm working with civil engineers I've done a fair amount of work with, but nothing like this. I'm working with a new MEP. I mean, the team members are new, but the way we run it is not. That's part of what I think adds to the value of the building is the fact that we set up a specific culture around integrated project delivery. So my rule was we had a meeting every Friday and everyone had to be there. From day one, I had my civil engineer, my master builder, me. I had our civil engineers and I had our landscape architect, and I had our pickleball consultant. every Friday for about 6 months. The outcome of that is we have very few change orders on jobs. My goal is to have as few dumpsters as possible. And you can see from the building type, this is an assembly. We're actually not cutting, hammering. There's some screwing as we attach panels to steel, but we're not fabricating on this project.
That reminds me, how are the panels joined to each other?
So they'll stack vertically, tongue and groove, and then they have butt joints on the end. And that's the joint I am concerned about. But, this is a well tried and true product. There are details on how to do that. So we'll probably put like a backer rod in there, put MP1, and we'll detail that. Most critical thing is what I said about the fact I have my little magic wand. And after you stack 6 panels, I'm wanding your panels. Not because I'm trying to get you and none of that. It's just we all have a commitment to performance. So we need to incentivize everybody to deliver to the top performance first time. And so we build those kinds of incentives in as well.
You said you're working with a new MEP, and yet you started out saying that MEP is like critical to any project there. So
yeah.
Why is it that you went looking for a new one, and why did you choose this team?
So the irony of Passive House is, as somebody who's had to manage properties for a couple of decades, my number one dislike is our HVAC system. It's the machine that breaks. It's the one that isn't getting serviced properly. It is 80% of my work with a property is dealing with air conditioning here. The irony of Passive House is, I thought I was just doing building physics and figuring out the R values of wall panel. No. Once you do all that, we need to ventilate the space. And now we need to, right? So it's all of that. So begrudgingly, I got pulled, and now I'm kind of enjoying it. But what I meant was, so I went to a mechanical engineer. I went to 3 different mechanical engineers here. I told them what we were doing. I got bids. I went to one that someone suggested I really should try and work with. And I went to them. I said, listen, I need to tell you, I'm a certified Passive House consultant. I'm not coming here just accepting whatever you send me. We're going to dialogue and design. And I said, so if you want to revisit your bid with that in mind, please let me know. Well, he raised the price by $10,000, which is his way of saying, I don't want an educated client, in my opinion.
Right.
So I went to somebody I've known for a long, long time. I said, can you just get me a building? We're doing a Passive House building. Just do your thing. And his thing is, what's typical around here is we'll just slap some packaged terminal units on the outside, run some big, ugly, you know what I'm talking about, right? And we had 7 of those. And all I could think of is my beautiful baby has this horrible stuff, right? Never mind the electrical and the circuits and all the stuff. So as we went through the past, I knew we were going to do this. So I said to him, Robert, can you just get me a building permit? And then I want you to know I'm going to go hire another consulting engineer who's going to help me redesign for Passive House. We'll come back to you, give that to you, and then we'll resubmit, which he was fine with because he didn't know how to do it. And that's the problem. There's really nobody in my market down here who does. So I ended up working with Galen Stengel out of Virginia, who's part of the Passive House tribe.
Right.
And he was great. And now I've got this. I mean, it was kind of cool for me because I'm so used to mini split system, the chocolate and vanilla. And suddenly I've got this 17-foot long swag-on thing with Frankenstein bolted on pieces to accentuate that. And things I didn't even know about, right? So it was really cool and really complicated. And I'd say relatively expensive, but we dropped from 35 tons down to 20. Of that 22 is maybe 2 weeks out of the year. So we saved money. I got most of my equipment inside the building, right? I've got one or 2 outdoor condensers. And I've simplified my building. So I don't have 7 pads around it. So I cut out 4 electrical circuits, which whatever wire's expensive. And I don't have these ugly things crawling up my building. Mm-hmm. So it was a really elegant design, but that just speaks to there's not enough engineers in the space yet that have experience, at least in our market. Here in this climate, we're a great solar opportunities here, right? And so this building, in this where we are, a 14-degree slope due south is optimal for solar. This building has a 16-degree slope due south, and it's like 35,000 square feet of clean roof surface. So of course, as we get into this modeling, and I mentioned the EUI metric, right? As soon as we get into the energy utilization intensity, and I see we're below 20, we should look at solar. And solar gets us to net zero with, I think, a 100 kilowatt array. But putting it up there is easy. And I'm looking at saying, this is the kind of building where you should put as much solar as possible and become a distributed energy provider. Because my math was we could get 200 to 300 kilowatts.
Kilowatts up there. Wow.
Almost half a megawatt. Yeah. So, but that's a big investment, et cetera. But we have looked into that. We have looked into other uses like just painting the top of the roof with a fun sign. But keeping that thing white, clean, and super tight was the objective.
Great. Let's talk about investment, the financial performance, and how you optimize the investment outcomes, because it's such an unusual building type for a passive house.
So when I say financial performance, that includes being efficient in our construction, obviously. All the other elements come into play, our capital stack, how much debt, equity, all the stuff. And then what our return expectations are. And for a building like this, of course, it's different than for an apartment complex, than different from a commercial office building. So I put that in there because unless it's your personal residence, there is a business purpose to this construction, right? We're not just doing passive. For a long time now, I've been talking to my buddies in the oil and gas business. We don't talk climate at all. I talk money with them because they get that. And so my approach to them from a financial perspective is maybe a little bit off topic, but it's just to say, I don't know why you don't want your building to be worth more money. Oh, well, I do. Well, let me show you how, right? So if I bring this building to net zero and I don't have a utility cost, I may have a loan payment that may be a one-for-one swap, but debt is treated differently, right, on the P&L than a utility expense. So it impacts my net operating income differently than a utility expense, which means my NOI is probably larger. When applied against a market cap multiple, now my building's worth more money. And that contributes to my long-term performance. So my background's in investment management, honestly, before doing real estate development work. And so this whole thing about, it's still an investment. We still have to hit our numbers. I don't care whether you're passive house or not passive house. To me, personally, as an investor, it's relevant to be passive house because it says this building was well built, because you can't hit the numbers without building it well. This building had a lot of thought put into it. It's probably efficiently designed from a mechanical perspective, for example. So I'm going to have a better building. This building is not going to have utility costs, so my NOI will be higher over time. So that adds to my return metrics, right? But at the end of the day, whether it's passive house or not passive or code built, I still have performance to deal with. And I think one of the greatest contributors for passive house is minimizing my maintenance costs, right? Because I have a more durable building that I built, minimizing my utility costs. Here we look at water efficiency too, right? Our big issue is water. So we're looking at water stuff. Well, if I'm planting as much water as I'm using to irrigate, maybe I don't need to irrigate as much. So I'm saving that has nothing to do with the building. That's more the whole project. But when I say financial performance, we need to generate market competitive return variables for investors.
Is thermal comfort as important for people who are playing pickleball as it is for, or is it still maybe as comfortable is not, as important is not the key question, but is it still important to athletes to thermal comfort?
That is a great question. And I actually don't even know. And I don't think that people think about it. So I've gone to a few indoor facilities around here to kind of check things like, what's your set points? How do I feel? Went to a new one in Austin. And it was actually pretty good. But I pointed out to everybody, you're feeling a little clammy, aren't you? I said, yeah, it's because the humidity is not being dealt with. I don't know if the courts down the end of the way or feel like, because they've got these roll down metal doors with no insulation on them, and they're facing the west. They're probably little radiators in the afternoon. I don't know. And then one of my associates went to play at another facility. I think it was in Bastrop, Texas. And he took a picture of the thermostat. It was set at 65 degrees. And he said, it was great when I was playing, but I started cramping up when I wasn't. Mm-hmm. So I don't think people are thinking about it. So I've been experimenting. I've been a little bit of a thought experiment where I don't talk so much about thermal comfort as much as indoor air quality, right? Like, and I'm planting the seed because nobody thinks about it. But I like your question. And I think what'll be really interesting is to answer your question a year from now and say, have we received comments on the air quality? So remember, I mentioned there are four approaches we use. One is heating and cooling is separate, mechanical ventilation. We do dedicated dehumidification, which in this case was an added on DX coil that with post heat, and I don't even understand how it works, but I know what it is. And then we have high volume, low speed fans, the big ass fans, just barely moving. Because I know from passive cooling strategies about a 5 mile per hour breeze, just gently moving, not enough to move the pickleball, but enough for you to feel just a little breeze. You add all those together. My goal is to set it right at the 77, 78. It's how I live here, where I am. 77,
Wow,
78.
77, 78.
Yeah. But I keep the relative humidity low at 55, 60%. And that's a game changer here. A little bit of air movement. And I test people now. I say, hey, what do you think the temperature is here? Oh, it's like 73. No, it's 78. And it's that 5 mile per hour. I think, as I recall from one textbook, I think that 5 mile per hour breeze reduces your temperature sensation by 5 degrees. Just the breeze. So We're trying to marry all these together, keep it at 77 with the thesis that you're comfortable sitting around and you're also comfortable when you're playing.
And the construction hasn't started yet, right?
Oh yeah, we're pouring our footers for the foundation. We should have a slab in the next 3 weeks. Steel goes up in December, and we should be open in March.
That quickly.
Yeah.
That's great.
Yeah, that's the advantage of assembling a building.
And that was David Komet. And I'm guessing you might be right, Mary. At the top, you said it's probably the one of the first passive house pickleball facilities. I don't know of too many others that fit that bill. I don't know. I know there is a community space in the UK with a swimming pool and a gymnasium, and I'm pretty sure there are some other of those recreational facilities around that have been certified to passive house, but I'm not sure about a specific pickleball facility. I've never actually played a game myself, so I'm not the expert on
well,
pickleball.
You just happen to have an expert here on the call.
Really?
Yes. So do you know where pickleball comes from?
I have no idea. I just think it's a hilarious name.
Very. So pickleball comes from Bainbridge Island, which is like right across the water from where I am in Seattle. And my stepdad's parents were good friends with the inventor of pickleball. And so they had a pickleball court in their backyard. And when I was in high school in the 1980s, pickleball was well known enough in the Seattle area that we did pickleball in gym class. And I, because of my training at my stepdad's parents' house, was the champion of my high school gym class in pickleball. That is my athletic claim to fame. Eddie. So it is incredible to see pickleball take over the world the way it has. It was this
along with passive house.
Yeah, that's right. That's right.
Yeah.
Right.
Well,
in his presentation, which I don't think got mentioned here in this interview, but he said something about there being around a 200% annual growth in.
Yeah.
So, hey, passive house, I'm sure is right up there with that.
That's true. That's true.
Yeah.
Passive house probably has a lot to learn from pickleball.
That's right. That's right. Do you get hot and sweaty when you play pickleball, Zach?
You do get hot and sweaty. I think that he mentioned the 65 degrees Fahrenheit inside a pickleball facility. That sounds about right, honestly.
Yeah.
Because you get moving for sure. Yeah.
I thought that was really interesting. I'm kind of jumping to the end, towards the end of the conversation where he was talking about the focus on indoor air quality being as much about that humidity level And I know that is, I mean, that's relevant anywhere. But coming back to those previous examples of community centres and sports facilities, recreational facilities, swimming pools are the worst. But if you can control that humidity, that really makes a big difference to comfort. And I think that's incredibly insightful for someone who has taught himself PHPP and has basically become a bit of a building physicist and a building scientist, probably unknowingly, because he spoke about many concepts which a lot of designers struggle to get their heads around. That it's not just about temperature, but you've got to consider the humidity and also that impact of just a small amount of air movement can have a massive impact on comfort, particularly when you're dealing with overheating and maximum temperatures being your design constraint rather than being freezing cold and trying to keep warm. What were your main outtakes, Mary?
Well, there were so many, but just building off of that, I just thought it was a creative way to address the whole thermal comfort. It was a creative solution for addressing thermal comfort in this facility. And I loved, he said something somewhere in the interview about, I really like when things, less is more, when I can do more with less. And that just seems to me to really, in his thermal comfort approach, play out there also, that he's figuring out how to set the temperature a little higher, but still keep it comfortable for the athletes inside. So that's great.
Yeah. Any other key learnings for you, Zach?
Well, I was taken by his anecdote about communicating, like talking about projects with his oil and gas buddies, and that it's not really he's not talking about climate action with them. He's asking, why don't you want your building to be worth more? And I think that and it sounds like that's resonating. And then he went into the discussion of the net operating income, and we were just before taping this, I think the three of us were talking about how it'd be great to dive deeper into those numbers and tease them out and really understand what all of David was saying there. But back to the why don't you want your building to be worth more? It makes me think of the progress that we can make, there's some parallels in renewable energy as well, right? Like Texas is I think the nation's leader in renewable energy production, and that's not about a climate activism. That's just about dollars and cents.
Good business. Yeah. I think there's a lot to be learned from people who have been successful in property development, realizing how to make that case. He said, as an investor, it's relevant to be Passive House because it says that the building was well built. It's a really good mark of quality, regardless of anything else, like you say. And if you're making a business case for an investment, then if you've got a way of making sure that that's going to be a quality asset, then that's got to be a good thing. And I think that what you're talking about, when he's communicating with oil and gas sector, is about knowing your audience and really understanding what their drivers are and pitching to them. And as engineers and architects, we're not always the greatest at selling, and we are. That's an important part of the job is to sell the idea, sell the vision, before we get to sell our services and our consulting onto a job. So I think we could learn a lot from that sector on the finance side. I'm really pleased that he used the term value engineering a couple of times, which I'm quite keen on, as opposed to cost engineering, and thinking about because a lot of time value engineering is about just taking out cost, as opposed to what value can I add to the project. Because if we're stripping away things to get a project under budget, often that means that we're taking off the things that are really going to make a difference to the performance. So yeah, I'm quite interested in that whole concept of value engineering and what that really means. So much in there, really good stuff. Any final thoughts from you, Mary?
Well, just how he drew from the Passive House community. You know, he got help from Andrew Peel. He got help from Galen Stengel. It's great that we have this community of resources that we can draw from. And at the same time, he brought his own decades of expertise to dealing with the climate that he's in. And I just thought, you know, it may be surprising to people that, I forget exactly, an R8 wall or whatever it was that he was using would be a passive house. But in his climate, it's really way more important to get insulation in the roof than it is in the walls.
Yeah.
I mean, so as long as it's airtight, that's the important point.
Mm-hmm.
You know, so it's just that combination of local knowledge and yet being able to draw on the wider passive house community is great.
Yeah. I think that's a real skill, knowing what you're able and willing to learn yourself, and then also having the humility to go and ask for experts where and when you need it. And he demonstrated that with like I say, going and getting help with PHPP, learning it himself, but understanding that there were great people like Andrew to come and assist. But also standing his ground with the ventilation and knowing he kind of knew what he wanted. And he also knew that some of the experienced providers in that field were probably not going to give him what he wanted first up. And that takes a bit of, I guess, experience and wisdom to say, these guys are going to sell me a whole bunch of plant, and I know that I don't actually want their normal sized air conditioning unit because we're going to do things a little bit differently. So there's obviously a bit of experience and good thinking and a good balance of self-confidence in his own knowledge, but also willingness to go and seek external advice from trusted experts. Really good stuff. Looking forward to seeing some more pictures. I think there are some pictures of that project online, but I'm looking forward to seeing more of it because, I quite like that look of the solid sort of white brick as well. I think it's going to be an interesting building when it's finished. So look forward to checking that out. Zach, what do we got coming up?
Yeah, so this week on Wednesday, we have the Next Up edition of Passive House Accelerator Live, and we'll be joined by Timothy Locke, who will be presenting Path Towards Zero, Material Choice in Low Carbon Design. And that kind of tees up, because it's next up, the month of December, both in the Reimagine Buildings Collective and at the Reimagine Buildings Biomaterials Conference. We're going to be diving deeper into low carbon design. So let me start with the Biomaterials Conference. That's December 6th. We're producing this in a collaboration with Chris Magwood of RMI. Chris is one of the top leaders in low embodied carbon awareness building, and also helped develop the BEAM tool. Just has been playing a really important role in this space of low embodied carbon and biomaterials, and exploring the possibility of using building materials to sequester and store carbon as well. And so we're going to be diving into all that with real world examples and the best kind of go-to solutions that are available now, and see how those solutions are being applied in the real world. So please join us on December 6th for the Reimagine Buildings Biomaterials Conference. You can register for that conference in one of two ways. You can register a la carte for the conference for $49, or you can choose to join the Reimagine Buildings Collective, which is $49 a month. and you can cancel anytime. But if you join the collective, you get access to the Reimagine Buildings Biomaterials Conference free, as well as all the recordings of previous conferences, the courses that Ed May has produced, both for PHPP and now for Woofy Passive. These are both 10-week courses that dive deep into modeling, and be part of the community forum where you can connect with people like David Komet, who is a member, and Galen Stengel, his mechanical engineer, who is also a member. So if you're wanting to take the next step and connect with building professionals who are stepping up to tackle climate change, we really encourage you to be part of the collective. It's been a lot of fun. We're almost at 100 members already and growing fast. So
that's fantastic.
Yeah.
I mean, even for those courses, that price is good value.
It is, and those courses eventually will charge for those courses in the future, probably starting maybe Q2 of 2025. But right now we're offering them for free, which is kind of crazy. I mean, it's a ton of content, and basically Ed will prepare you to be able to model a project for a paying client by the time you're done with the course, either in PHPP or in Woofy Passive, or if you're insane, you can do them both at the same time. And there are a couple of, given the community that we're part of, there are a couple of people who are crazy enough to do it. So all the power, more power to them.
Awesome.
Yeah.
Lots going on. All right. We can stay in touch with all of that and more over at the Passive House Accelerator, passivehouseaccelerator.com. And we'll be back again next week with a regular episode of Passive House Podcast.